Welcome to TOC class. In this class, we will discuss about additional forms of proof. So this is the second form of proof category. First one is formal proof. Formal proof is categorized into two groups. Sequence of steps means that those all comes under deductive proof. Iterations of steps means those proofs are comes under inductive proof. In deductive proof, four different categories are there: deduction proof, reduction to definition, other theorem forms, and theorems not in if-then format. So we already discussed those four concepts. The second type of proof is additional forms of proof, which contains four categories. One is proof by set theory, proof by contrapositive, proof by contradiction, and the last one is proof by counter. So let me discuss proof by set theory concept. So if you go for a set theory, if you take E and F are two expressions, those representing any format of expressions, we can able to say the statements E and F are equal. So how it is possible? Again, we come to the properties by using commutative law. Union of two Z's are equal, which means that R union S equal to S union R, here in which R and S are two sets. For example, we should prove this concepts: R union S intersection T is equal to R union S intersection R union T. Let us try to prove this concept by proof by set theory. So we are in need of proving R union S intersection T is equal to R union S intersection R union T. So now consider the LHS part. We are taking expression E is equal to R union S intersection T, and F is equal to RHS part R union S intersection R union T. So we can take it as, if X is in E, then X is in F, where X is a variable. And we prove, if X is in F, then X is in E. We should prove this theorem. So consider if part, that is, if the element is in E. What is your E? E is R union S intersection T. Then we should prove it as X, either it may be in R, otherwise X is in S intersection T. And further we can write it as, either the X is in R, otherwise X element should be in S and T, isn't it? So by the commutation law, we can write it as X is in R, otherwise X is in S. This is one category. And X is in R and X is in T. We can say that if you combine R, S in a notation, we can write it as X is in R union S and X is in R union T. Then we can sort it as X is in R union S and the operation is intersection R union T, which is nothing but X is in F. Here we prove the RHS part, therefore LH is equal to RHS. So this is the set theory proof. The second concept is proof by contrapositive. So what is the contrapositive? If any statement is like if H then C form, its corresponding contrapositive statement is if not C then not H. So how can we prove it? So not C means negation C. Not H means negation H. So we should prove by the rules. That is, we are taking hypothesis and conclusion. What are the possibilities? Either those conditions are true. If hypothesis is true, conclusion is true. If hypothesis is true, conclusion may be false. If hypothesis is false, conclusion may be true. If the hypothesis is false, conclusion may also be false. So if H then C equivalent notation is H implies C. So in a discrete mathematics, we are aware that true for H implies C, it is true. True false means false. False true is true. False false means false. This is the notation for H implies C. Then what is the contrapositive statement? We should take negation C and negation H value. Whether those truths are equal or not, we should prove it. So consider C. So what is negation C? Negation C means opposite value. So if C is true, negation C is false. This is true, false, true. Negation H means the opposite of H. So its value is false, false, true, true. So what is it? Negation C implies negation H. So the answer is, if any true false is there, the answer is false. Otherwise, the answer is true. You see, the answer of H implies C and negation C implies H. H implies C is if H then C format. Negation C implies negation H means if not C then not H. So hence it is proved for contrapositive statement. So the same, that is H implies C's equivalent statement is this one. This is called as contrapositive statement. And the third type is proof by contradiction. So what is contradiction? If it is if the hypothesis is true, the contradiction is false. If hypothesis is false, contradiction is true. This is the contradiction statement. So if H then C, it will be written as H implies C. Then the contrapositive statement is if you combine H and negation C, the answer should be false. So how can you prove it? Let us take the same notations for HC concept. So the possible values may be true, 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 false, false, true, false, false values. H implies C means the answer is true. This one is false, true, true. And we are taking negation C. Negation C means false, true, false, true. What is contrapositive? H and negation C. H and negation C, it is false, true, false, false. So if you take H and C, that is H implies C is opposite of H and negation C. So this is the contrapositive statement. So the same one is for, we can already prove this concept in reduction to definition. That is, each one will be taken as hypothesis. So the same concept will be proved for contradiction. Contradiction means first we should take T is finite. So we try to prove this concept. S is finite and if T is finite, both are subset of infinite set U, then U should be finite. But the given condition is the universal set is an infinite set. So there may be a contradiction of taking T is finite. Therefore, T should be an infinite set. So in this way, we can prove it. Then the next part, proof by counter method will be discussed in next class. Thank you.